Before we can go on to the next part of building our interactive game and processing, one of the things that we're going to need to help control the flow of the game is a timer. The good part is processing has the ability to build in a timer class. And we'll do that by taking advantage of one of the methods it has, which is millis, which allows us to know how many seconds, or how many milliseconds, thus millis, have elapsed since the program started running. And we use that by calculating how long it's been running versus what is the time when we start our timer. So we'll go into all of that here as we're going to build our timer class. And it's the same kind of thing that we do, where we have our properties, constructor, and finally our methods. So we do things the same whenever we make a class. So we need to have our start time as part of it, and then we're going to need to know an interval. The interval is what is the frequency that we want our timer to be counting on. So think of it this way. We can set up our timer so it will count seconds. We can set it up so it counts partial seconds. We can set it up so it only will count every couple seconds. So it all depends on how fast or how slow we need our particular timer to run. Now when we do this, what we're going to do is we're going to be passing a value to the constructor. So every time we make the timer, we're able, because we don't want it to just be fixed where the timer is giving us just milliseconds and we have to do calculations on the fly each time. We want to be able to create different timers. So this is really a utility class. So we pass this value into it, and then we will set the property in this class of interval to that value that is passed into it. That's really all there is to our constructor. Now we'll have a couple methods here that we use with our timer. We need to be able to tell it to start, because the timer, it will run for a particular length of time. And what we do is we check and find out, hey, is it done running? If so, then we can either do nothing, or we could tell the timer to start over again. So if it runs every second, we keep checking in our draw loop to go, hey, is the timer done? And as soon as the timer pings and says, hey, yeah, I'm done, then we tell it to start over. So this is how we use our start method, where we will say our start time is going to be equal to the time at which we call start. So remember that millis starts running when the program starts running, and it just keeps pinging up. So if we call start after it's been running for 10 seconds, millis would be equal to 10,000. Remember that it's giving us 1,000th of a second values. And then we need a method that we can ask the timer, hey, are you done yet? And to do that, we're going to set it up so it returns a value of true or false. So we keep asking, are you done? Are you done? Are you done? Kind of like that annoying kid on a road trip in the back seat. Are we there yet? Are we there yet? And we keep saying no, 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 no. And finally we'll go, yep, yeah, we're there. And at that point we return true. Otherwise we keep returning false. Now we're going to calculate how long the loop has been running by creating a variable that exists only inside this function, and that is elapsed time. And that is going to be equal to the current time minus the start time. Then we're going to use a conditional. So if our elapsed time is greater than the interval, meaning the timer has been running long enough, because elapsed time is our total time that the program's been running minus the time that it started, and if that elapsed time is greater than the amount of time that we want our timer to be running, then we return true. And if that's not the case, else return false. And now we can also see complete is happy at this point because it's now returning something. If we don't have these returns in our Boolean, our function says it returns a Boolean, that's a problem because it needs to return a value. Now when we start getting all these curly braces stacked up like this, sometimes it gets a little bit hard to track what is going on. So I hit Command or Control T to auto format. But what I like to do on the final curly brace is just put a little comment in and go and if, because that's the curly brace that goes with the if. This is end complete. And we can even just go down here and end class. So putting those comments in at the end of a closing curly brace helps us to know what its partner is, what it belongs to. And when we end up with stacked ones like this, it's really easy to have things get misplaced, where we miss a curly brace and then our program breaks and it gets really grumpy. And when we start using classes where we have curly braces nested in there, then we have our main function, it's got curly braces, sometimes when it highlights where the error message is, it's a little bit off. It doesn't work quite right. So that's where we need to help ourselves out. And if you put the comment on your closing curly braces, it does make your code a little bit more readable. And that's also part of why I always like to have these same 3 comments in every class, so I know that I'm keeping what I'm doing here organized. And I can put a little extra white space in to make it more legible, more white space. I can even push that final class one down. So having those extra lines of white space does make my code a little bit more legible for the human. The computer doesn't care, but the human does. Okay, now let's deploy this and let's work with this timer. Along with working with the timer, because this program is just going to run the timer and show it's going to count up, it's going to count down, we'll try out some different things. You need to learn a little bit about how to display text on screen when we're working in processing. So we can do that. We're going to learn a few of the basic commands for putting text on screen. So right now we need to set up a few variables here. So I have capital T timer, lowercase t timer as my variable name. So then hopefully that makes it easy enough to keep track of what is going on. So the capital T refers to the class, the lowercase is the variable instance of my timer. If I have different timers, I could set up a count up timer, a count down timer, a game timer, a shot timer, all kinds of different timers. If I have different ones running inside my program, so each one is running on a different interval, then I want different variables. If what I'm doing is running on the same kind of time interval, I can usually just use one timer to do everything. Now, what we want to have with our timer is I'm going to want to know what is the current time. I'm going to just store a value for that. It makes it easier to display it on screen. Now, we're going to add a few more timer things along the way, but we're going to just start with the current time, and then I want to have a string, and I'll just call it S. Now notice string has a capital S in the data type, and that's because it is a string refers to multiple characters. Now character is a single letter that we display on string. a string is multiple characters together, and because it's a composite data type, then it's not a primary data type, so it is capitalized, much like when we make our class timer. So string is a class to be particular, specific on it. And then we have string methods and other things that we can do where a character is just a character. So that's why when we are going to data type string, we use the capital S. Now, what I can do is go timer is equal, well, lowercase t, my bad, timer is equal to a new, now capital timer, like this. But I have to pass a value in. We'll see right here, the constructor timer does not exist. It's waiting because the constructor wants me to pass a value in. So in this case, I'm going to pass in a value. I'll just say 10. I want my timer to run for, or my bad, not 10. I want my timer, I'm going to run for 10 seconds. Or however long. Well, right now we'll just let it run as long as we want. But I want it to ping, I want the timer to be 1 second in length. So we're getting that full 1 second of timing happening. And well, once we can see it on screen, I think it just makes it a little bit easier. And then we're going to set s equal to, we'll just start it out as an empty string. Okay. So now here inside my draw loop, and I already put in a background command so it can wipe the background or clear it, because when we're displaying text on screen, it'll just keep drawing the text over the top of itself, which gets really ugly because you can't read anything. So I need to clear it, but we're going to have timer stuff, and then I'll have my text stuff. So we'll first go into the timer here and set that up. So what we do is we say if timer.complete, so we're calling the complete method, is equal to true, then put in my curly braces here. So if the timer is complete, then I can say current time plus, my fingers missed. I'll move my cursor so we can see what I'm typing. So current time goes up by 1, and then we tell our timer to start. So that now tells the timer to run a second time, and a third time, and a fourth time. And again, once we can see it running on screen, I really do think it gets a lot easier to understand what is happening there. So when we're working with text, we want to set a fill color for the text. We need, well, the fill color is whatever, the color the text is going to be. The same way you say fill and then you draw a rectangle, it's that color, or a circle, or a triangle, or an ellipse. It's the color it's going to be. So I'll say fill, and we'll just fill it with white. Then I'm just going to put a few extra returns here so I can move my stuff up on screen. And I don't want that extra return there, just keep things tidy. When we're working with text, we can set our size by going text size, and we specify our size, it's a pixel dimension, so I'll just say 48. So that makes it big. So standard text on screen is 12, so we're making it bigger. I want my text to be centered. So we use the command text align, and then our options are left, center, right. So we can put in what we want. No quotes around it, but it is all capital letters. So those are constants that have been set up inside the language. Thus, they show up purple. If you misspell it, so if you have it wrong, you can see, it's like, well, what is that? And it doesn't turn purple. So we don't put quotes around it. It's just all uppercase, like that. Now, I'm going to say s, my string, is going to be equal to, and now in quotes, current time is, put a space, close my quote, put a plus. And now what I'm going to do is just say current time, my current time variable, put that in. And now the thing that we've been waiting for is I want to write this text on screen, and we do it by saying text, and then the text we want to put on screen, so we just use a variable here. So technically, could we do it without using a variable? We could just put the quotes and plus and current time. Absolutely, we could do it, but it makes your code a little bit easier. And now I'm just going to center it on screen, so I'll do half the width and half the height. So we're putting in our x and y coordinates for where we want to draw it. So the same way as if we're drawing a rectangular circle or something in the center of the screen, that's what we're doing. We centered the text, so it will put it there, and now if we run it and all goes well, we can see now it's counting. Started out at 0, and then after a second we got 1, and we can see it's going at 1 second intervals. Now if I change this to say 2 second intervals, we'll see that now the count takes a lot longer before it goes. Now if I change it to a half second, we'll see that it starts counting much faster. That's part of it. So every draw loop, it checks to see if the timer is done. If the timer is done, current time goes up by 1, and then we tell the timer to begin anew. And the timer will always be going based on this time interval. So that's really all there is to working with a timer. And this allows us to count up so we can see how long something is going. So if we say create a game where it's how long can you last, so that the time just keeps going on, and your score is really based about how many seconds you were able to survive, then counting up is a great way of doing it. Counting down is a little bit different, and we have to deploy things slightly differently. We'll need a few more variables to store our information on that as well. To count down, what we're going to do is set up our countdown time, because we have our current time. So I'm going to add in another variable here, and this is going to be, so we have the current time and then countdown time. So countdown time is going to start at whatever we want our max time to be. Now, in this little example, we're not really using max time because we're not kind of running a whole game where we end the game and then we want to reset the game and do things, where it's much easier to store things in variables when we start doing resets and we have lots of pieces in play while we do it. So right now you'll kind of be thinking, well, that seems like overkill. Do I really need to do that? And the answer is, for this example, no, but as we start building more complex things, we probably want to. Now I do realize I forgot to provide a starting value for current time, so it should start out at 0. One thing that processing is good about is if you forget to initialize a variable, like if I just said string s and never put any value on it, it would be an empty string, like what I did. Other languages, if I tried to then use that, it doesn't do a default initialization to my variable, so it would throw an error. And I'd be like, well, I have the variable, why is it not working? Well, I have to provide that value. So even though processing provided a current time value of 0, a better practice would be to set that value. Processing doesn't care, but other languages do, so getting in good habits is going to serve you down the road. Now, I want to set my max time, and I'm going to just set it equal to, initially we'll just say 10, so we have time to talk while it's running. once I prove that's working, we'll probably just cut it down to 3 because we don't want to keep running it over and over and over, and it takes a long time to count down from 10 once you've proven something can work. And this is also why it's nice to just have it assigned as a variable. So countdown time is now equal to my max time. So what it means is if I want to change the length of my countdown timer, I just go and change max time. All my other code is going to work perfectly at that point. So that's pretty awesome. That's one of the good things about that. So this is where I'm going to add in some close in curly brace comments here. I'll call that end complete, because what we're going to do right now is we're going to say, hey, if downtime, countdown time is greater than 0, then we want to update the current time by going up. Tell countdown time to go down by 1. We tell the timer to start. And then I can put in my close here. So if we do this, and we've done everything right, and we can hit stop to 10, but we didn't get to see our countdown time because we need to update our text string. So we have a couple ways that we can go about doing this. I'm just going to auto format to clean up my indents here. Always a good idea. Here, what I want to do as well is once it's done, I just want to change the background color. Now remember, if I draw a rectangle that fills the whole screen, at this point it will happen before I fill any of my or write my text on screen, so the text will sit on top of what we do here. So I'll just go fill 255 0, 0 and draw a rectangle from 0, 0 to width. Let's try again. With height. And then here, end. I'll just go CDT for countdown time. So we have end complete and countdown. So by doing these comments, it helps us to better remember what kind of goes with what. So we can click on that curly brace and see how that's happening. So there's two ways that we could do this. I want to put my text on screen. I want it to be on 2 lines. One is I could say s plus equals. So the same way that we can add to numbers, we can also add to a string. I can say countdown time is, notice we're always putting a space after the last letter, so then that will, before the closing quote, that extra space means the number won't be right up touching it. If we forget that space, then our number is touching it. And we go countdown time. Alright, now if we run this, see what it looks like. We can see it's all on 1 line, but I want 2 lines. Well, the shortcut for doing it without having to call the text command twice, I mean, we could do that. We could call the text command, then we could do it, and we could offset the vertical position and push it down. That's just kind of ugly. But we can insert a character of line return, and we do that by using /n. Now the slash here is the one directly above the return key on the keyboard and right below the delete or backspace key. So it's that slash. It's not the one at the bottom of the keyboard, it's the one higher up on the right side of the keyboard. /n gives me a return character. And now we can see And now it switches to red once our countdown has finished. So I'm going to modify max time. I'm just going to set it to 3 so it happens a little bit faster. And boom, it works. So as I said, there's different ways that we could do this. We could also, instead of doing the plus equals, this just allows it to be really organized when we're looking at our code. But we could just as easily just put a plus here and do that. But you can see how my line length now gets kind of ugly. I have to really scroll over. I try to avoid doing that whenever possible and prefer doing something like this because when I look at the code, we can see I have my string and it's going to be equal to the text plus this variable. Then we're going to add to that and we use our line return, and then we have more text plus the variable. So then that gives us what I would argue is a significantly more legible. And I suppose you could even go s plus equals and just put your line return here. So that's on its own line. And then you have this here, making it really obvious what is happening with your code. So I'll leave it up to you to decide how you want to go about doing it, but know that making your code more human readable only benefits you in the long run. I prefer just doing it like this. I mean, we could even do the plus up here and just go plus, because we think of the line return as happening as part of, that element. So you could put that at the end. That works too. I prefer at the beginning. For me, that works well with how I like to organize it. So we're able to count up, we're able to count down, we can change the length of the time by what we want that to be. And the same way that we have our max time that we are setting here, we could store this in a variable, because if we do that, maybe we want to change it. So maybe we deploy our timer, instead of just telling the same one to restart, we create a new one with a different time interval each time, so that we want the timer to start out slow, and as our game progresses it gets faster and faster and faster. So we'll look at some ways that we can do that as we figure out how to integrate this into our interactive thing catcher, whatever style game that you are going to be making.